Thank you very much, Eduardo. Thank you all for coming. We have a very good representation of members of the U.S. government. We have our partners from CAP coming all the way from Chile to accompany us in this important date. We have the full Aclara board. No, we had our board meeting earlier today at the Virginia Tech campus. We have Dr. Aaron Noble, our host today. We were discussing yesterday at dinner that in February of last year, we had our first conversation here at Virginia Tech, and 12 months have passed, and you'll see how impressively fast we've been able to move. At Aclara, it's all about our speed of execution. We know that these minerals are critical, so we are prepared to, deploy all of our resources in terms of professional talent, economic resources, etc., in order to make sure that the U.S. has the rare earths that they need as soon as possible. I have a very short presentation to introduce Aclara, basically, and what we're doing, no? And I wanted to start with a statement that we want to be in production on a vertically integrated way, no, by 2028. We started, as Eduardo mentioned, our origins are from the mining industry in Latin America. We started by developing these two deposits in Brazil and Chile, but we figured that clients or customers here in the US, they don't want to buy dysprosium or terbium or things like that. They need to buy magnets. They want to buy magnets. And that's what we need to deliver. And there's a big gap between the mining and the production of these magnets. That's where we want to develop our technologies. We are going to be quite unique through this integration, precisely because our deposits have a very high concentration of the heavy rare earths, which are the really rare earths. And we want to do this by 2028. It's a very aggressive schedule. Right now we are on track. We need to move very quickly. We need funding, of course, hence our deep conversations with the U.S. government. There are members of the DFC here today with whom we have already signed a preliminary agreement. We have started to receive funding from the DFC, and we look forward to deepening those conversations. What sets Aclara apart? This is a slide that I took from our presentation for investors. No, they want to know why we're unique, why we're different, and why to invest in Aclara. And I would like to summarize that advantage in three different pillars. The first one is we have the type of deposit that contains the heavy rare earths. No, this is copy-paste, the type of deposit that the Chinese have in their southern provinces, and what provides them with that competitive advantage. We have one deposit in Penco in Chile and one deposit in the state of Goiás in Brazil. But not only that, through the past 7 years, we've been able to develop a technology to extract the rare earths from those clays in an environmentally and socially sustainable way. This is crucial, no? Again, we have 110 years as a group doing mining in the Americas. We know that we need to work very closely with local communities, and we need to make sure that we protect the environment in doing so. So we have developed a system that fully recycles water, that fully recycles the reagents that we use, and that it doesn't have tailings dam. No, so we're doing something that we have baptized the circular mineral harvesting. This is an innovation that we have patented and that is quite unique in the world. But we produce out of those processes a carbonate, and without the next steps, that carbonate would inevitably have to go to China for processing. How do we avoid that, and how do we bring it to the US? So we decided to vertically integrate, also with the support of our board here 2 years ago. We decided to pursue separation of rare earths. Again, this is a technology dominated by China, and we wanted to develop that in the US. We started looking for the best partners that we could find not in the US, but in the world. We found Virginia Tech University with a lot of experience on that front. We have found the Argonne National Laboratory, of which we are going to be talking soon. We found L3 Processing and Tommy La Rochelle, a fantastic company that has been supporting us in this effort. And we have put an internal team that is, I believe, unparalleled, in the Western world in order to achieve this. And you will see the first fruits of their work. It's this pilot plant, which is the stepping stone through which we will build these facilities in the US. So the combination of having the mines together with the separation and then the alloy making, we have partnered with our Chilean partners in CAP. CAP is a company that has also 70 years old of experience, doing ferroalloys. And the magnets for electric vehicles are no other thing, or robotics, there are no other things than ferroalloys. So we are leveraging also on their experience and adapt that to produce the alloys that are going to be used in the permanent magnets. This proposition is unique. No one else in the world can claim to have 2 ionic clay deposits outside of Southeast Asia, and have a plan to integrate and process all those rare earths all the way to the alloys here in the US. And how is this possible? And this is our third pillar. It's not small thing that we have shareholders that have a long-term vision. Why do I say this? Because this is a business about credibility. What we're trying to do is provide clients with a supply chain that is reliable, that is sustainable, and that is consistent through time. If the different stages of that supply chain are in the hands, for example, and nothing wrong with that, with venture capital funds or other type of financial entities that are in the business of buying and selling businesses, you know who they are today, but in 2, 3, 5 years, you might be facing very different people. Here, again, let me emphasize that the long-term vision that we have through the direction that we receive from our shareholders makes the whole difference, and allows us to think differently on how we approach this challenge. And I wanted to put a summary of how the integration would look like. I've discussed already many of these points. The part that I didn't mention is we have a strategic partnership with Vacuum Schmelze. They have built already a magnet plant in Sumter, South Carolina, with General Motors as their client. So we already have a very clear path on how to integrate all the way from mine to magnet. We are not going to be working only with VAC. We're open to conversations with other magnet makers, so keep that in mind. But the path already exists to support this type of clients. We do not have offtake agreements yet, but this is the type of companies that we are targeting. Now, something very interesting is this type of chart, is just a PowerPoint slide. And many companies can claim similar things. They do, in fact. We're integrated. But at Aclara, what we're doing is absolutely real. And I wanted to show you some pictures, try to cram them also into one slide. But we have the deposits in Brazil and Chile. We have the circular mineral harvesting. We have, this is very important, and only miners typically know about these details, but companies typically have inferred resources. They move them into measured and indicated resources, and ultimately you need to have reserves. We have reserves already at Aclara that have been determined under 43101, which is the Canadian standard, which is the highest standard in the world. Then you have to demonstrate that those reserves can be processed properly, so you need to develop metallurgical processes. We have built 2 pilot plants. You can see a picture there. The first one was built in Chile. The second one was built in Brazil, in Goiânia, so that we have demonstrated at a pilot scale, semi-industrial scale, that processing those clays and converting them into high purity carbonate that you see there in the middle is feasible, is possible, and we have demonstrated that. That carbonate is what's going to come here to Virginia Tech, demonstrated in in the pilot plant that you will visit today, and that will set, the base for the plant that we're going to build in Louisiana, which is already underway. You can see there already a diagram that the engineers have produced. By the way, we have hired Hatch, one of the top, if not the top engineering company in the world, to oversee all this process. So we have not gone, to the cheapest alternative in each stage, but rather go to a highly reputable firm to oversee everything that we're doing in order to ensure and minimize the blind spots in this, complex process that we're pursuing. From there, we have already produced at a lab level pure metallic dysprosium. No, you can see it there in the picture, and we have developed using our own technology an electrolysis cell, which is needed to take the oxides that are going to be produced in the separation plant and convert them into the alloys. No? And then in the bottom, what you see is the plant from back and a sample of the magnets that are the final product. No? So as you can see, this is not a conceptual chart anymore. No? This is actionable. We're working on it, and that's why we believe that we could be in production by 2028. There are a lot of factors that we need to make sure that are there in order to be really credible. No, we strongly believe in the partnership with academia as a sort of insights and innovation. We're not here at Virginia Tech by accident. No, as I mentioned, we look for the best possible partner to work together. We are working already with several of Dr. Nobel's PhDs that are already overlooking at our process, looking for risks, looking for opportunities, looking for better ways on how to do what we are already doing. We believe also in the team. You can see there the team that is operating the pilot plant. We decided to go to Louisiana also because of the experienced workforce in the chemical industry in the region. And we partner with the Argonne National Laboratory because we strongly believe that the future is going to be highly influenced by artificial intelligence. And the question is, how do we use artificial intelligence in order to improve these processes? This is a race, no? This is a race. The race has already started and China is well ahead of us. How can we catch up? Through innovation, and we believe by applying artificial intelligence. So we have developed a digital twin, or we're in the process of developing a digital twin with the help of Argonne. Argonne, if you're not familiar with them, they are the top laboratory in the world using AI and exploration or development of digital twins on rare earths. So bringing them together to this partnership with Virginia Tech, ourselves, our partners, I think is also a quite unique proposition, and one that will ensure the reliability of our production of rare earths going forward. That's it. No, we believe that the goal for the U.S. to have these heavy rare earths in 2028 is within credible reach. Thank you very much.